Tonight we're going to be looking at isosceles and equilateral triangles. For the most part, you should know what both of those things are, but what we're going to look at is theorems that are used in both of those and things that we can say are true about isosceles and equilateral triangles. So first of all, with isosceles, you should know that that is a triangle with two congruent sides. So what we need to do is kind of discuss what different parts of an isosceles triangle are called. Okay, so I'm going to label this triangle over here ABC, and we're just going to talk about the different parts of this triangle. First of all, the two sides that are congruent, so here AB and BC, those are called your legs. Okay, those are the legs of your isosceles triangle. The side that is not congruent to any of the others, so here AC, that's called your base. It's the base of your triangle. All right? The two angles that touch the base, so here angle A and angle C, they both touch that base AC. Those are called your base angles. And the other angle in that triangle, angle B here, that is called the vertex angle. So it's important that if you were given an isosceles triangle, you would be able to list all of these things. You would be able to tell me what's the base, what are the base angles, what are the legs, and what is the vertex angle in that triangle. So the first theorem we're going to look at for today is called the isosceles triangle theorem. More commonly, you're going to hear that called the base angle theorem. And that's actually, until this book, that's what I've always heard it called, the base angle theorem. And what it says is that if you have an isosceles triangle, then the angles that are opposite the two congruent sides are congruent. So here we have that AC is congruent to CB, so therefore angle A is congruent to angle B, since those are the angles that are opposite those two congruent sides. And that is really, really helpful for us. So for instance here, if angle A is, say, 60, angle B is 62, those base angles measure the same. The converse of this is also true. The converse of the base angle theorem, or the isosceles triangle theorem, simply says that if two angles of a triangle are congruent, then the sides opposite those angles are also congruent. So here, if angle A is congruent to angle B, then you can determine that AC is congruent to BC. Okay, because those are the sides that are opposite those two angles. All right, so let's go ahead and, using those theorems, see what we can conclude from the following picture. We want to know if AB, so here I'm going to label side AB, is congruent to side CB, and then explain if it is, why it is. So here, the key piece of information is this, is that angle A is congruent to angle C. So since angle A is congruent to angle C, I can say that AB is congruent to CB by the converse of the base angle theorem, or isosceles triangle theorem. So that is a plenty of explanation. If you want it, you could go into detail and say because angle A is congruent to angle C, then AB is congruent to CB. All right, let's look at part B. We want to know if angle A is congruent to angle DEA. Angle DEA is right here. And we have that AD is congruent to DE. So yes, we can conclude that those two angles are congruent. So angle A is congruent to angle DEA. And that would just be by the base angle theorem. It tells us that since these two sides are congruent, I know that those two angles opposite those two sides are. So that's by the base angle theorem. Okay, so let's look at part A and we're going to move on. We won't look at part B. So let's look at part A. Is WVS, so WVS is this angle here, is it congruent to angle S? Okay, so are those two angles congruent? Well, yes, they are. So the first answer to this question would be yes, they're congruent because of the base angle theorem. So you just need to make sure you know whether it's base angle theorem or whether it's converse of base angle theorem. And then we also want to know whether or not TR is congruent to TS. And so if we look at those, we know that those two base angles are congruent. So therefore, yes, we can say that those sides are also congruent, and that would be the converse. So just make sure you know whether or not it's the converse or it's the plain base angle theorem. All right, we're going to go a step further and look at one more theorem that's used with isosceles triangles. And what it says is if you've got an isosceles triangle and you have a line that bisects the vertex angle of that isosceles triangle, then that line is a perpendicular bisector of the base. So here we have CD, and CD bisects this vertex angle, that top angle. So because of that, I know that angle D is a right angle, so CD is perpendicular to AB, and also that AD is congruent to DB. And that is very, very helpful. And we'll look at the proofs of this along with the base angle theorem tomorrow. So let's go ahead and look at this problem, and then we're going to talk about equilateral triangles, and we'll be done. So here we want to find out the value of x in the following picture. So we have that A is 54. So since this is an isosceles triangle, I can also say that C has to be 54. Agreed there? So what I can do now is I can figure out what this green angle measures. So that green angle there will have to be 180 minus 54 plus 54. So when we work that out, I get that that angle there, if I do 180 minus 54 plus 54, I would get 72 degrees. So that whole green angle is 72. And then if I wanted just that red piece there, that would be 72 divided by 2, because that angle is bisected. And so I would get 36. So that angle, the value of x there would be 36. Okay? So the last thing I want to do really quickly is talk to you about, first of all, what in the world a corollary is. Because I know you probably see that word and you're going, what in the world did she just make up? Okay, so a corollary, it's kind of silly, but it's just a theorem that can be proven or that follows another theorem. So it's just really a theorem that comes from another theorem. So the first corollary we're going to look at here is this one. It doesn't have a name. And it just says that if a triangle is equilateral, then it's also equiangular. Equiangular just means all angles are congruent. It just means all the angles have the same measure, okay? So here you can see that all these angles, and this just follows from the base angle theorem. If we looked at the side opposite this, we would get z, the side opposite this, we would get x, and then here we would get y. So that just really follows from base angle theorem. It just requires one more step. And then the converse of that is also true. So if a triangle is equiangular, then we know it's equilateral. Okay, all the sides are congruent. And this comes from the converse of the base angle theorem. So that's all we're really going to say about about equilateral triangles. Now, equilateral triangles are isosceles, so anything that's true about isosceles has to also be true about equilateral, okay? So what I want you to do now is pause this, try out these 3 questions. I'll be looking at these tomorrow in your notes, making sure that you have these. And when you unpause, I'll have all the answers out for you. Okay, so here are the answers to those problems. Number 1, A and B, those are pretty self-explanatory. For number 2, you were given the vertex angle. So if you subtract that from 180 and divide by 2, you get each base angle in that isosceles triangle. And then in part B, I just wanted to show you kind of a different way to approach that than the way we did it in the previous example. Here, we know that this is a right angle because we're told that if it bisects the angle, it's perpendicular to the side. So that means that this triangle would be x plus 42 plus 90. So if we subtract what we know from 180, we get that the value of x there is 48. And then in the last one, the measures of the other angles in that isosceles triangle would be 34 and 23.